Okay, hi everybody. This is just a little extra explanation video for exercise 20 of lesson 2. And you were asked to take the expression a plus b times a plus b and use the distributive property and rewrite it. So this is the same as the expression a plus b squared. But that's not using the distributive property, but that is a correct expression for that. But what we want to do is something a little different. So we're going to use the distributive property. So one of the things that you may have seen before is how to use an area model for doing multiplication. So I'm going to draw a rectangle here, and it's actually going to be a square. But it's going to be made of rectangles, and I'm going to put the dimensions. A and B are just numbers, right? They can stand for any number. So I'm going to choose for A to be this shorter length here. So this length of this segment is A. The length of this segment is B. And then I'm going to put the same lengths over on this side of my square. And then I can finish off the square like that. So I have a square, and the area is going to be, the length of this side is a plus b, and the length of this side is a plus b. So the area of this square is a plus b times a plus b, right? So that's the area model for multiplication. And I can divide my square up this way. And when I do that, it's nice because now I can find the area of each of those individual rectangles and squares. So I can find the area of that square right there, and it's a times a, which I'm going to write as a squared. All right. And the next one right there, the dimensions of this rectangle are b times b, or b squared, right? So there's my a squared and my b squared. Now I have two more rectangles to find the dimensions of. And so let's start with this one. So the dimensions on this rectangle are a times b, right? So this one's not a square. This is a times b. It's a rectangle. And so I could write its area as just ab, or a times b. But notice that this rectangle right here has the exact same area in this case. This rectangle is also a times b. So I'm going to have to add a times b and a times b to my a squared and my b squared. Okay, so now I've got this expression down here, but I can simplify it a little bit more because I can combine the two ab's. So now I have a squared, which came from here. AB plus AB is 2AB. And then I have plus B squared. So what we've shown is that this expression up here is the same as this expression down here, which is what we showed on the video as well. But I didn't do it with the area model. I really like the area model. It really helps to show where each of those individual terms is coming from. But we can also, so what we did here is we used the distributive property, but I want to show you again how that works. Okay, so distributive property would have you do something like this. So if I had A times this quantity B times C, what I would want to do to use the distributive property is I would take A and multiply it by everything in parentheses. So I would have A times B plus A times C. That would be using the distributive property. So how's that going to work with this slightly more complicated, let's use a different color so it stands out. Orange. Okay, so what if I have A plus B times A plus B? Okay, how am I going to use this distributive property here on these expressions down here? Well, what I'm going to do is I'm going to think of a plus b, this one right here, I'm going to think of it as just one thing. I'm not going to think of it separately. So I'm going to do this a plus b times a. Let me show this with arrows. So I'm going to use this a plus b times a, and I'm going to do a plus b times b. Okay, so I've got a plus b times a, and then I have to add that to this a plus b times b. So then I've got a plus b times b. Okay, so then once I've done that, I have these two expressions, and they're just like this one, except that I have the single number on the outside here, on the back. It doesn't matter. It could be up here at the front, right? Because multiplication is commutative, so that means it doesn't matter what order I multiply these things in, it's going to be the same. So I'm going to have a times b plus a times a, and then here I've got b times b and b times a. And if you look at it, I'm going to have a times b plus a times a, which is a squared, plus a times b plus b squared, which looks very familiar now. So I've got my a squared, my b squared, and my 2ab. So this is a squared plus 2ab plus b squared. All right. So that's basically it. So you've seen the area model using the distributive property, and then you've seen how you can do it just with algebra as well. Okay, hope that helps.